we have the height of the person to the height of the tree is 6 to 30. What's got to go here?
30?
30 is already there.
Oh.
The 8, right? That's the person's shadow. So this is the person's real height. That's their shadow height, the person to the person, right? So down here, this will be our x. And if you cross multiply and divide, this does come out to be 40. Any questions? New material. So we've looked at these similar shapes. So I'm going to take a triangle like this. I'm going to erase that and try to draw it a little bit better. Let's say this is a right triangle, and this is 3 inches by 8 inches. Now I'm going to take this triangle, and I'm going to duplicate it. I'm going to do this to it. Just like we have been, we're going to blow it up. So now this side is 9 inches. What's this side have to be down here? How'd you get 24 inches? Use the ratio of lengths, right? We had a ratio here. This is 3 to 9. And then you used, okay, 8 to blank, and you cross multiplied and divided, right? You get 24 here. So the ratio of lengths was this 3 to 9. I'm going to reduce it to a 1/3. 1 to 3 ratio of lengths. What is the area of this triangle? 3 times 8 divided by 2, or 1/2 base times height, which is 12 square inches. What is the area of this triangle? 9 times 24 divided by 2, which is 108 square inches. What is my ratio of areas? It is 12 to 108. Can that be reduced? Yeah, what can they both be divided by? 12. It's 1 to 9 ratio. Interesting. The ratio of areas and the ratio of lengths is not the same. Let's look at another one. Another example here. Let's say this is 2 inches by 2 inches. It's a square. And I'm going to blow it up. It'll be 8 inches by 8 inches. What is the ratio of lengths? Well, we have 2 to 8, which reduces to what? 1 to 4. What's the area of the little square? 4 square inches. Right? What is the area of the big square? 8 by 8, or 64 square inches. My ratio of areas turns out to be 4 to 64. This can both be divided by 4. Give me a 1 to 16 ratio. So when I had a 1 to 3 ratio of lengths, I ended up with a 1 to 9 ratio of areas. When I have a 1 to 4 ratio of lengths, I end up with a 1 to 16 ratio of areas. Do you see the link? Yeah, the ratio of areas is the ratio of lengths squared. If I take 1/3 and I square it, 1 squared is 1, 3 squared is 9. I take 1/4 and I square it. 1 squared is 1, 4 squared is 16. The ratio of areas is the square of the ratio of lengths. So that means if I know the ratio of lengths, and I know one of the areas, I can find the other one. So let's say I've got a weird shape like this. And I know that this is 4 inches here. And let's just blow this thing up a bit. And let's say that this now expands to be 7 inches. And I somehow managed to find out that the area of this is 80 square inches. And I want to know the area of this. Now, what is my ratio of lengths? 4 becomes 7, right? You need me to slow down for a second to catch up? Okay. It's not fun trying to draw those freehand in your notes? So our ratio of lengths, the 4 becomes 7. So that means our ratio of areas would be found by taking that 4/7 and doing what to it? Squaring it. What's that going to become? 16 over 49. 4 squared is 16. 7 squared is 49. Now, what's going to go over this other side of our proportion here? This is going to be areas. We know the area of 80. Does that go top or bottom? Top. Because that comes from the figure that had the 4, the side of 4. So we shall cross multiply. Oops, that's not the other one. 49 times 80 divided by 16 is 245. Yes? So the area of 245 square inches. What do you think? Not terrible? Well, good. Oh, no, it's not. Let's get back here. So, we have this weird little shape here. And you know that this length here is 8 inches. And on this one, it has been expanded to be 12 inches. The area of this one is 128 square inches. Find the area of the big one. I'll give you a minute to do that in your notes. Okay, so we have our ratio of lengths. Which is going to be 8 to 12, which I'm going to reduce to 2 out of 3. Ratio of areas, take that 2/3 and we're going to do what to it? Square it. What's going to give us? 2 squared is 4, 3 squared is 9. So yes, 4/9. What's going to go over here? 128, top or bottom? top. So we shall cross multiply and divide. We are going to get 288. Is our area? What do you think?
I just forgot to turn that into a ratio.
Oh, this? To reduce it? You could square the 8 and get 64, and square the 12 and get 144. It'll still work out.
Oh, really?
But even if you don't reduce it, it'll still work. They're just bigger numbers to work with, is all.
Yeah.
Good enough. Pi, where? My job on this earth is done. Said my job on this earth is done. I want you to find X and Y for me in your notes. So we've got the 15 and the 25 that match up. I'm going to find X. X is from the same figure as the 15, so I put X there. Matches up with the 30. We cross multiply and divide to get that X is 25, right? You let me get away with that? What's X? There we go.
We want to see a reaction.
Yeah, I was just letting everybody's just nodding here today. It's like, okay. X is 18. So 15 still goes to 25. Where's Y going to go? 15 goes to 25, right? They're both the heights. Y goes on bottom because it's from the same figure as the 25. What goes above the Y? 12. We cross multiply and divide, we get what? Y equals 20? There you go. So we've got X and Y. What's that? It's green. So now, if I tell you the surface area of this one is 390 square inches, find the surface area of this one. So anyway, this one here, our ratio of lengths was 15 over 25. I'm going to reduce that to 3 over 5. Both of those can be divided by 5. I got to square that now to give me a ratio of areas of 9 to 25. So the 390 goes here. If we cross multiply and divide, we get 1,083.33333. If I tell you that the volume of this one,
I knew it was coming. I knew it was coming.
so if I tell you the volume of this one is 2,330, actually 430 inches cubed. What's the volume of this one? Well, we haven't done this yet, so let's talk through it together. We've still got our ratio of lengths. It's 3 to 5. Now, just speculating, what do you think the ratio of volumes is going to be from that? Cubed, right? We squared it to get the areas. We're going to cube it. So 3 cubed is 3 times 3 times 3, which is 27. 5 cubed is 5 times 5 times 5, which is 125. Feeling we're going to have to add. So 127 over 27 over 125 is a ratio of volumes. So we're going to put 2,430 up here. And we will cross multiply 125 times 2430 divided by 27 to get 11,250. There you go.
Also, and yet I didn't pass that test, so.
So anyway, let me give you guys another one.
Oh, I get it. Scroll the name.
So I'm going to tell you that the surface area on this one here is 600 square inches. I'm going to tell you the volume on this one here is 2,160 cubic inches. So find the surface area of this one and the volume of this one. Okay, so what's our ratio of lengths here? 6 to 10. Can we reduce that at all? 3 to 5. For the ratio of areas, take the 3/5 and we're going to square it. So it's 9 to 25. What goes over here? 600, top or bottom?
Bottom.
Bottom.
Nice try. No.
You get 216? Yeah, you gotta remember that comes from the big ones. It's got to go on bottom with the big one. So for our volumes, we have the 3 to 5 lengths. What do we do to that? cube it. So 27 over 125. We have the 2160, top or bottom?
Top.
Top.
I was right there. I'm
You
just
didn't say
following
bottom
your
left?
lead. You didn't ask me one question either.
Didn't buy a bottle.
So you got 10,000 for the volume. $150.
150?
It used to be. I haven't watched Wheel of Fortune
I
for
haven't
10
watched
years.
it long, I
I bet your friends have got up.
used to watch it. Inflation. Like a 1,000.
Wow.
Really mad taxes for life wise. I'm talking about a different one. That's Pepper. Price is wrong in this case. No, it's math.
Okay, so here's a problem I'm going to give you. We have the length here is 12. We know this figure over here is an enlargement of the other one. We've got the surface areas of 1408 and 2200. This one's got a volume of 16,000. I want to know what x is. Now I know what this volume is. So we don't have a ratio of lengths here. A ratio of lengths is 12 to x. However, we do have a ratio of areas, which is 1408 to 2200. So we can do this.
I'm just doing a bunch of stuff that we can't do. Now I know that we can do.
So 12 squared is 144, and x squared is x squared. So we cross multiply 144 times 22, or 2200 divided by 1408. Gives us 225. So x squared is 225. Does that make sense? We cross multiply and divide, we got 225, but that's x squared. So now we got to square root it, which means x is 15. X is 15 inches. Now I bet you can find the volume. So we've got 12 to 15, which is going to reduce to a 4 to 5 ratio. For volumes, we're going to do what to it? Cube it. It's a 64 to 125. And we have the 16,000 is going to go on top. So we're going to take the 16,000 times 125 and divide it by 64. 31,250. What do you think?
I just didn't know about that, that we were taking the areas and stuff like that. I don't know what I was thinking. So
Okay.
yeah, now I kind
Well, the first step is admitting it.
yeah, right.
First step is realizing that.
Holy man, I want that though.
The hard part when we get into applied problems is trying to decide, are we dealing with volumes, we're dealing with areas, what are we really dealing with? For example, let's say we've got a pipe discharges 4,500 gallons per minute. In fact, I'm going to amend this here. I'm going to call this a 6-inch pipe. Discharges 4,500 gallons per minute. How large of a pipe is needed to discharge 13,500 gallons per minute? Is this an area problem or a volume problem? It sure looks like a volume problem, doesn't it? What can we change about the pipe? The size. What about the size? We can change the diameter, right? We can go from the 6-inch diameter up to whatever diameter we want. Is that going to change the volume? No, it changes the cross-sectional area. Right? So all we're changing here is an area. To change the volume, we would actually have to change the flow rate of the fluid coming out of the pipe, which we're assuming we can't. That flow rate has to stay constant. So we're changing an area. So our ratio of areas here is going to be 4,500 to 13,500. Both of those can be reduced by how much? Let's say 500 to start with. This is going to be 9 over 27. They still be reduced by 9. Gives us the 1-to-3 ratio of areas. So now we come back to our lengths. We've got the 6 inches. That's the smaller one, right? We got X is going to be the bigger one. We're going to square that. 6 squared is 36. X squared is X squared. So 36 times 3 divided by 1 is 108. X squared is 108. So that means we got a square root 108, which is going to give us 10.39. X is 10.39 inches. Does that make sense? Because that's the ratio of lengths, and we're adjusting the areas to increase the volume, the flow. Even though it is a volume, and we want to increase the amount of fluid we're getting out of there, the volume fluid, we can't change the volume, we're only changing the cross-sectional area. The amount of fluid that comes out of the pipe is determined by the cross-sectional area. Yeah. I'm going to give you a worksheet, and on this worksheet, it's labeled page 250. I want you to do 1 through 16, and I do want you to do all of them. Let's see how you do.
And you want these quizzes from there or what?
Are you going to need to take the quizzes home over the weekend and finish them up? Are you going to be done before you leave? You're going to be done?
It's done.
You're going to be done, then put them on the pile. That'll be the worksheet for you.